All right, folks. So if you stuck with me this far through this ice table stuff, congratulations. This is a tough one. So we are going to do another equilibrium problem. This time it's going to be not so straightforward because we have initial concentrations of all three species in this reaction. So for the equilibrium of 2 nitrous oxide is in equilibrium with nitrogen gas, oxygen gas at 300 Kelvin. The equilibrium constant is 0.00260. If 0.820 moles of NO, 0.223 moles each of nitrogen and oxygen are introduced in a container that has a volume of 1 liter and allowed to reach equilibrium at 300 K, what are the concentrations of N2, O2, and NO at equilibrium? Okay, so you see here I've already got my ice table set up. So I'm going to fill in what I know to begin with. Notice I put the species across the top, its initial concentration, change in concentration, equilibrium concentration across the column or down the column. So initially I start out with 0.820 moles per liter of NO and 0.223 moles per liter of N2, and the same with oxygen. So right now, I don't know if this reaction is going to shift left or shift right. So I've got to find my reaction quotient. So I'm going to come over here, and reaction quotient is going to be the concentration of the N2 and O2, not for initial, not all divided by the concentration of NO squared. And I'm going to say that's going to be 0.223 times the 0.223, all divided by the 0.820. And when I, and that's squared, excuse me. And when I solve that out, I get a Q, a reaction quotient of 0.0740. And I'm not even caring about units at this point because this is an important piece of information. It is larger than the Kc value given of 0.00260. So what that tells me is when Q is larger than K, we got to shift to the left. We got to shift to the reactant side. That means the concentration of the reactants has to increase. So we're going to shift to the left, to the left, to the left. That means we're going to add some NO, and we are going to subtract some N2 and O2. So I'm going to add here, I'm going to subtract here and here, because I'm shifting to the left, to the left, to the left. And then, I don't know how much I'm going to shift it by yet, but it's going to be double the amount of what I'm going to do for my nitrogen and my oxygen, because I've got a molar ratio of 2 NOs to every 1 N2 and 1 O. And so at equilibrium, my expression is going to be 0.820 plus 2x, and then I'm going to have 0.223 minus x here, and the same thing here. All right, now this one's going to involve some algebra. I am going to want to figure out what x is, and that's going to give me my equilibrium concentrations. So I'm going to set up K. I'm going to set up K to equal the concentration of N2, concentration of O2, all over the concentration of NO to the second power, which I can fill in the expressions that I got up here. I will find that this is going to be 0.223 minus x. This is going to be 0.223 3 minus x. This is going to be the 0.820 plus 2x. And I also know this all equals 0.0026. All right, now here's where your algebra savvy comes in. And this is going to be more algebra than anything else from here on out. I'm on extend page. So my goal is to find x from this expression. Well, I'm going to recognize here that I can rewrite this as 0.223 minus x squared. Oh, and I forgot to square that up there too. Divided by 0.820 plus 2x squared equals 0.0026. Well, that looks complicated to solve, but I also recognize I've got a squared on the top, I got a squared on the bottom, so why don't I just square root both sides? And if I square root both sides, I will be left with 0.223 minus x, all divided by 0.820 plus 2x, and the square root of 0.0026 is 0.0510. All right, still doing this algebra thing. So now what I'm going to do is I'm going to get rid of the fraction by cross multiplying. So to do that, I'm going to say 0.0510 times the 0.820 plus 2x equals 0.223 minus x. So I'm going to distribute here. And when I distribute, I end up getting 0.0418 plus 0.102x equals 0.223 minus x. I'm going to add x to both sides. I want to get all my like variables together. And so I'm going to end up with 0.40418 plus 1.102x equals 0.223. I'm going to subtract 0.00418 from both sides. And that's going to turn into 1.102x equals the 0.1812. I'm going to take a little side note here. Sig figs in problems like this, IB doesn't assess on sig figs with complicated problems like this. So don't worry about sig figs through every step of this. This is kind of a nightmare to do. So we're just not going to worry about them. Yay. And I'm going to divide both sides by 1.102. And I'm going to find out that that number of moles that I'm increasing and decreasing is 0.164. I'm almost done, I promise you. So that's the number of moles I'm going to increase or decrease from. So we're going to go back up here. We now know this x is going to be 0.164. We know that this x is going to be 0.164. And we're going to realize this x is 0.164. And so, all right, so solving this out, the number of moles of NO I'm going to end up having at equilibrium is 1.148 moles per liter. I'm going to end up having 0.223 minus 0.164. This one is going to be 0.059 moles per liter. And same with this one. And That's going to be my equilibrium concentrations. Why is this useful? Because I know exactly how much product is going to be in my flask when this reaction has reached equilibrium. So my last double check here is going to be, again, looking at this K value that I'm given. This K value that I'm giving is incredibly less than 1. So I know that equilibrium is going to favor the left-hand side of this equation. And when this equation is said and done, I'm going to end up having more NO than I am going to have N2 plus O2. This is an endothermic reaction. It takes a lot of energy to actually break this back into its elements. And the reverse reaction here would be favored. Okay, thank you for sticking with me with this. I know there's going to be questions on this. I know that you are going to spend more time on this lesson than probably the other lessons that you've covered. So good luck. Please keep in touch so I know where the questions are.